class is finished, there's always like someone who comes up to me afterward and says, this is really great. I loved learning how to do StyleGAN and style transfer and all the other models you teach. But I want to learn, like, how do I keep doing this? Or how do I, if a new model comes out, what do I do? How do I like learn how to use it? So I want to record this little video of just like how I personally like go about exploring new models, and how I actually learn how they work. A lot of times these models are like half documented and aren't perfect, but there's a lot of information that you can glean from something like a GitHub repo. So the first thing we want to talk about is like, where do you actually find like new models? So like there's a couple places you could look at. There's stuff like R machine learning, that's on Reddit. There's a lot of people who post here about new models or other things they see. The downside is it's a little tricky. It's not really meant for artists. It's sort of meant for a general machine learning community. There's also things like arXiv Daily, which I believe is, let's see, I think that's like a Twitter account. It might be another service as well. Yeah, arXiv Daily. So again, here they will post different articles that come in through arXiv.org. Again, I sort of just follow this and I just sort of like keep an eye on models as they come through. So it's worth checking out. The other place I really recommend looking is just go into Runway. So I've got a bunch of videos on Runway, and Runway is a really great place because there are different folks out there who are constantly porting new models into Runway. There's one guy, Sri, that's how you pronounce his name. But I think his job is just to like port stuff to Runway. So he's got lots of new models, lots of interesting ones that come up, and it's worth checking out. There's also like some YouTube channels that'll tell you about sort of like the newest papers that come out and that sort of thing. That's sort of the best place to find new models and check them out. So, once you've found a model you want to work with, then you have to sort of figure out like, okay, what are the steps I need to do? So in general, like one thing I've been recently doing is I've been trying to research some good super resolution networks. So there's been a couple over the past couple of years that have come out, and each of them has slightly different features and that sort of thing. So, one thing that I've been looking at is something like ESRGAN. So this is, one of the models to look at. And, then you come to a page like this and it's GitHub and you're sort of like, okay, how do I approach this? So there's two things you could do. One is like you can read the paper. The paper will tell you like what they're trying to accomplish, why they're doing it, why they think their results are better than other folks. But at the end of the day, like what really helps me is like actually looking at GitHub and trying to understand the code, and then using Colab to actually like test stuff before I like move it over to like a model like Paperspace. So the problem with like moving stuff to Paperspace is that there's generally a lot of dependencies you need to install. You're paying money for it, and if you like get frustrated and feel like you lose a couple hours, like then you're like, now I'm paying for this. So I like Colab as a place to just start exploring a model and just sort of understanding how it works. And then figure out whether or not I want to like dive in deeper. So I'm gonna walk you through like how I would explore ESRGAN. This is pretty common to how I would explore most papers and most GitHub repos. But let's just walk through it and I'll tell you sort of what I see. So first thing I usually do is I come here, I just look at like, when was the last commit? So sometimes you'll find a paper and it'll sound really cool, and then you look and you like, oh, the last time they committed anything to this was 2016. And 2016 was a lifetime ago in terms of machine learning. So in general, like if the commits are from like 2017, 2018, that's okay. But in general, I want to look for something that's like pretty recent. And this was updated most recently on September 16th, 2019. I'm recording this in February of 2020. So that was like that was like 5 or 6 months ago. That's pretty good. That just helps me know like how up to date these are. Because again, in machine learning, everything moves really quickly. Next thing I usually look at is just like sort of read through the top of this. So it looks like, okay, maybe there were a couple other things that were like a couple other papers they've written and they merged them all together. Looking at like, okay, they do other work that's interesting. Maybe one of these is actually more helpful for what I'm doing. So maybe I am really looking for like video super resolution. That's like cool to know. Like actually this is like a pretty well done GitHub repo and that they're telling you to do lots of other work. Usually there will be a link to like their paper or some other like, thing about what they do. And then as I go here, like, okay, so there's a frequently asked questions. That's good. Like, I will also tell you that for a lot of machine learning models, the code is just kind of dumped into a GitHub repo, and there usually isn't a lot of documentation. So if there's, like, I'm already seeing this is pretty well documented, which makes me really happy because it means like there's a lot of stuff I can do here. So again, now I'm also seeing sort of like some image results. You know, they're like basically showing me that like the model I'm looking at looks better than this one, but not as good as ground truth, although it's pretty close. Like that's good. Seeing that there's like different training sets, that's helpful. Quick test. So this is like the first thing I want to look at. So cool. This is Python 3. That's good. Anything in Python 2 at this point is like gonna be really tough to work with, especially in Colab, because Colab I think stopped supporting Python 2 now. PyTorch is fine. PyTorch comes installed on Colab, so that's gonna be pretty easy to set up. Pip packages. A lot of the packages, they use the dependencies. They're already set up on Colab. Another great reason why I want to go ahead and do this, or like why I would want to do it in Colab. Next, test model. Okay, this is really helpful. It sort of has the code I need to do to test stuff. Place your low-res image in this folder. Download pre-trained models. Okay. So the other thing I would also recommend is like if you ever see a Google Drive pre-trained model, that's what you want to go with. I've always struggled with Baidu Drive. I don't know why. Maybe other folks are better off at reading Chinese than I am. But in general, this is like the thing I want. Python test, that's cool. So I'll generally like read through this entire page and like then I will come back to the top to make, so like as I'm going through here, I'm seeing different, you know, types of tests they're running. There's an interpolation strategy. So like maybe these are things that I want to look at once I've established that the model is really what I want. Here's more testing. So again, this is like this model, which looks a little bit nicer than the previous one. Bicubic is like, so if you ever have done anything with super resolution, Bicubic is basically like Photoshop. So like pretty clearly like this is like definitely better than Photoshop, that sort of thing. They've got different samples here. This is all really helpful. So again, I might like just like quickly read through some of this stuff. So I see there's some artifacting issues I may have to think about or keep an eye on. Patch sizes. So like I'll read through this and like maybe I won't understand a lot of it, but I'll understand like some of it. And that's fine. That's enough to get me started. So like I feel like cool. I like see everything here. I think this is what I want. I feel like I'm ready to test this. So now it's like time to actually start doing this in Colab. So I'm gonna pop over here to Colab and I'm just gonna start, I'm gonna create a new file, create a notebook. Now, another thing I should mention is actually like some of his people have already written notebooks for these things and you could just try using their notebooks. The problem with Colab is like it's not, like you can't search everyone else's repos. So it's like maybe hard to like find these things. So like maybe you just do a search, right? So it's ESRGAN, Colab. I see some things here like a TensorFlow hub. You know, maybe I want to do ESRGAN.ip, IPYNB. That stands for IPython Notebook. That's basically what Colab runs on. Okay, so cool. So there's someone here who has one of these. Let me look at it real quick. Actually, just inside of here, it looks like someone has. This is the actual repo, right? Colab implementation. And if I go back here, this was the paper I was just looking at. But I don't see it here. That's interesting. So like someone did a pull request for an IPython notebook, but it hasn't been merged in yet. So, okay, that's interesting. That's helpful. This is ESRGAN. Looks like someone this might have been someone who rewrote ESRGAN. This is a pretty common thing you'll find is that a lot of machine learning students will basically take a paper and rewrite it and then like learn how to like write TensorFlow or PyTorch using that. But let's just say like for whatever reason I can't find a Python notebook to play with. And also sometimes I'll like open these Python notebooks and be like, wow, this is way too complicated for what I'm actually doing, which is just like basic testing. So let's just assume that for a reason I can't find a Python notebook. So I want to write my own. I come over here, I create a new notebook. First thing I usually do is just name it whatever the repo is, just so I remember like, oh, that's what it is. First thing you always want to do with IPython is or with Colab especially, is you just want to git clone the folder you need. So they already have this here. It's always git clone and then just whatever this GitHub address is here. So let's just come over here and do this. So I'm going to do git clone and then I'll paste that in. The other thing is to remember, because it's Colab, like you can't just run git clone. You have to actually put your little interrobang ahead of it or an exclamation mark if you don't want to be fancy. Then you just hit shift return. That's going to run it. So usually I'll pop open my files tab just so I can keep an eye on stuff. So that worked fine. If I hit refresh over here, now I've got ESRGAN. If I go back over here, obviously the next thing to do is cd into the folder. So another thing that's important to remember is like every cell runs its own, runs separately. So it's important that you don't hit shift return up here again, because all it's going to do is like reinstall that library again. So usually what I'll do when I'm testing stuff is I'll just like keep adding new cells, and then once I get to a good place, I'll like start to combine them and clean them up. So I'm just going to run this. That's just going to cd me into ESRGAN. Next is, okay, so place your own low resolution images in LR folder. So there's 2 samples already in there. So like, let's just work with what was already in there. The next thing I would say is like, always use what they already provide you. So if I go in here and I go to LR, there's already 2 images in here. Let's just start to make sure we can get this running, and then we'll come in and like start to do our own customization after that. So come over here. Next thing is download pre-trained models from Google Drive or Baidu Drive. So I always recommend Google. Like if there's Google or Dropbox or things, still just stick with Google, and I'll show you why in just a minute. I'm gonna place those models in the .models folder. So they provide 2 files, and then it's run test. Okay, so next thing I want to do is, it sounds like I want to cd into the models folder. Now I'm inside of models, and then I want to grab these pre-trained models. Okay, so there's a couple different files here, and which one do I want? Oops, I lost my GitHub. So provide 2 models with high perceptual quality and high PSNR performance. See model list. Provide 2 pre-trained models. ESRGAN X4 is the final ESRGAN model we used in our paper. PSNR is the PSNR-oriented model with high PSNR performance. Okay, I don't actually know what this means, to be honest with you. And that's something that's pretty common. Like, I'll usually go and Google it and find out. But it sounds like if this is what they're using in the paper, let's just use this for now. So if I go back here to the models and I grab this one, what you want to do is you want to get the shareable link. And then you're going to copy this. It looks like it's already copied here. I'm going to go back to my Python notebook, and I'm going to do gdown --ID. This is why you want to use Google, because it's really easy to work with this. And the next thing you want is you just want just the ID. So you're going to delete this stuff. This is what you want. Can't remember if I need. I think I need that. So then if I just run this, I'm already in the models folder. So this file should just download directly to models. Let's see what happens here. Also, I just realized they made a classic Colab mistake. So I'm actually going to fix this while I do some other things. So while I'm waiting here, I'm just going to start cleaning up some of this work. So I'm going to move this up here, and I'm going to move this up here, and I'm going to grab this again and move this up here. So like basically like when I come back to this folder or like this notebook, I know I'm just going to want to run these all at once. This is just like a setup cell. I'm just going to run everything all at once. And then I can just come in here and I can start deleting some of these cells just because I know I won't need them. So the classic mistake that I made is that I didn't set my runtime to GPU. So when you make a brand new Colab file, you always have to set up your runtime type. So it's really good that I actually just did this cleanup work because I think it's I'm gonna have to rerun this cell. So again, when I ran the gdown, it actually brought this file down here in the models. And like the other thing I'm gonna want to do is after this, I'm gonna want to cd back to my main ESRGAN folder. I'm not sure why this works sometimes and sometimes it doesn't with the cd, so I just like clean it up just to be sure. So what I'm going to do now is I'm going to go over here and change my change my runtime type to see how I don't have GPU acceleration. My guess is that for this file it's going to need GPU. It could run on CPU, but it'll run really, really slowly. So I'm just going to bite the bullet and switch this to GPU, and then it's going to delete my entire folder here, and I'm going to have to run this one more time. So see, ESRGAN disappeared, but I have a new GPU setup over here. So I'm just going to run this folder again, or run this cell again. And now that I know this works, I can like move it all into one cell and then clean it up. Cool, so now we're set here. So I also might like start, now that it's since Colab, I might start, saying, adding some text here about like, might just do something like install repo and dependencies. Like what's kind of nice about Colab is you can start taking notes for yourself. So one thing is like only use or download the ESRGAN.pth from drive. And then sometimes I'll make to-dos in here. So to-do research psnr .pth. Okay, so I've started to add a little bit of notes for myself here too. Let's go back over here. So we're ready to run the tests. So we provide ESRGAN model. Okay, so that's just config test.py. So here's where things get a little tricky is like, if you want to actually run a different configuration and you want to edit test.py. So if I come up here and I look at test.py directly in GitHub, so here's the thing that you could note, which is like maybe you want to change the folder that you're looking for things in. This looks like where you would change that file path. So it looks like you could change it to this. The tricky part of this is like you can't edit files in Colab. So if I were to come back to this and maybe edit it later, what I would actually need to do is like fork this repository into just stuff I want to work on, and then I might edit it, save that into GitHub, and then come back and like do a git pull and like update my notebook. For now, I just want to make sure this thing works, and I want to see what it does when it works. So like, let's just keep going ahead. So the next thing we need to do is I'm just going to add a little text up here, and I'm going to say quick test. And what did we need to run? We need to run Python test.py. So that's pretty easy. So again, because it's Colab, you want to add your interrobang, and then you're going to say Python test.py. So we're just going to run this cell and see what happens. Cool, so it looks like it went over the baboon image and then over the comic image. Let me open this guy up here and just sort of see what happens. So if I refresh this folder, I see LR. Results is probably what I'm gonna look for. So like clearly they didn't tell you like, hey, once you've run it, oh, actually they do, never mind, my bad. These guys are good at documenting stuff. A lot of places won't tell you where files end up, so you're just gonna have to sort of figure it out. The results are in .results folder. Cool, let's take a look. So results. And so I see baboon, ESRGAN, baboon RLT, comic RLT. I assume this stands for result. If I go back to the repo here and I go into the results folder, yep, baboon is already in there. So that's what that is. That's been sitting in there for 17 months. Usually people will do that because you can't really have an empty folder in GitHub. It like doesn't really work. So usually put in like a resulting image of what you might expect. So let me just download comic and let's see what this looks like. Cool, so that's a pretty interesting looking image. If I come in here and I just hit Command I to look at it, so it's now saying it's 248 by 360. So this must have been a really tiny image when it was started. Let's download the original. Yeah, so that was a 62 by 90 image. So that's pretty good for small, really, really small to like that. Like that's pretty decent. Cool, so now I know this runs. I didn't get any errors, which is great, because sometimes you'll find a repo and you're like, this sounds great, and then you run it and you run into a ton of errors. And I would generally say if you run into errors that you don't understand, it might be time to move on to a new repo. Unless you're like convinced that it's the perfect thing for you, in which case you might want to do some Googling or other things to find answers. That's not really what this video is about, but like you can figure it out usually by Googling or maybe looking even in the issues inside of the repo. Now I want to do one more test before I call it a night. I'm going to try to add my own images here and just sort of see what my own images look like. So let me see if I have any low-res images here. Where might I have low-res images? Oh, I know. I happen to be working on a project right now that is looking for low-res images. So these are sort of like some of my StyleGAN pieces. And they're 1024 by 1024, but let's say I want to print them a little bit larger. So let's grab one of these images. I'm just going to drop it in here. It'll always remind you that when your runtime ends, you're going to lose all your files. That's fine. I'm also just going to delete these 2 files in here. It looks like what happens is every time you run this, it runs over whatever's in your folder. So just for my own sanity, I'm going to delete those. I'm going to delete these results as well. And so let's run this again. So like, let me just open this. Let's open this in Photoshop and just take a look at it. So we'll see, like, this is 1024 by 1024. So when I 4x that using ESRGAN, that's going to be 4096. Is that right? My math worked there. Let's look. 1024 by 4. 4096. Okay, cool. My math is not terrible today. So that'd be interesting. That's like a 12-inch print, which is pretty great. So let's see what happens here. Like, so one thing to look at this image is like, you know, clearly there's going to be some blurriness. Clearly there's like a little bit of grain and like hard edge here. So what I want to do is when I actually run this, I want to keep an eye on this and see what happens to those pieces. So I'm going to come back over here. I've got this uploaded, so I think we can just run the cell again. My other fear is that because this is 1024 by 1024, it might not actually, it might max out the GPU, but let's see what happens. Oh, it actually worked. Great. Sometimes I've worked on smaller machine learning servers and that will not work. So that's pretty awesome that ran. Let's download this. That is a 30 megabyte image. That's pretty amazing. What was it previously? 2 megabytes. Okay, cool. So I'm going to pause the video for a minute, and once this is finished downloading, I'll take a look at it. File just finished downloading. We'll see it's here in my Finder, so I'm going to come in here and look at it again. And if I do a Command I, it sure enough is 4096 by 4096. And let me open this into Photoshop and let's take a look. And the next thing you want to look at is you want to look at it about 100% zoom. So, I mean, it looks blurry, but it doesn't look terrible. And also what's kind of interesting here is like, it kept some of this like really sharpness edge here. So I'm pretty impressed with this model. Like another thing that's really helpful to do is to do this. So just go in here and let's make this a little bit larger. So let's actually like res this up in Photoshop. So usually the way you would do this would be, let's say preserve details, preserve details 2.0. This is just Photoshop's algorithm to res up an image, right? So let's hit OK. Going really deep into super res for everybody. I'm gonna paste this on top of this. Did that work? It did. So the next thing you want to do is like, let's just zoom in a little bit, right? Okay, so that's that image. So, okay, so basically what I'm doing here, if you're not aware, is like this top image is bicubic. So this is just what Photoshop does. This next image is ESRGAN. And we're switching between the layers, right? So now this is sort of up to you as the artist, right? There's like this ESRGAN model like keeps a little bit of grain in here, right? There's like some graininess, whereas you can really see bicubic just blurs everything. And the question here is like, which is better? And this is sort of your opinion. I recommend if you're really going to do stuff for printing that you probably print both just to sort of see. Even if you do like test swatches or something like that at your local printer or at home. My guess is that this grain is going to be better for printing, but let's sort of see. So I'm pretty happy with this model, and maybe I just want to like start running this, right? So maybe I want to take all of these images that I've got a bunch of images here, and I just want to dump them into this Colab repo and just sort of start playing with it and see how it works. What I would probably do is, since I know I want to look at a couple different super resolution models, I might like do this same process for a couple other ones, and then what I would do is I would bring them all into Photoshop and place them all on top of each other, and I would zoom in to about 100%, and I would just start looking at them next to each other, right? So like at 100%, the difference here is like pretty minimal. You can see a little bit more grain when you switch to ESRGAN. You'll see that it keeps certain little detail here that it's losing when it goes to bicubic. But again, this is really up to you as the artist to sort of make the decision. I would look at a couple different models here, and then I could run them. What's nice now is like with this process, I basically have built a process for me to run super resolution all by myself for free on Colab, right? So like I don't need to run my own Paperspace server for something, the process like this, right? Because it's just testing. And I'm just using the built-in pre-trained model that they have already done. But let's say I really want to see if I can like train my own ESRGAN model. So let's come back here. Let's go to ESRGAN. And let's look at seeing how training works. So I don't actually see training here. So the question is like, can I train? I happen to know with this model that they have moved the training codes into a new location. So now this is in this other thing here. MMSR is an open source image and video super resolution toolbox based on PyTorch. So it's actually like they've combined a bunch of different things here. So like if I want to do training, I'd have to go over here and look. Data sets, codes, training and testing, see wiki training and testing, how to test, how to train, options, train. Okay, so like now I see that training is possible within this. I can see train ESRGAN. But this is going to be like a whole nother process, right? And as you know, like I generally don't recommend training on Colab, but what I do recommend doing is actually setting up all of this code first in Colab, running the training for like an hour or two, and just sort of seeing what happens. Because remember that Colab has a 12-hour limit, but it's free to try. So like you could set up all this code. This code is going to help you document what you need to do when you move it to Paperspace, but you're also going to like see where you run into issues. And if you run into issues and you like are spending an hour or two on Colab and it's free, that's great. Whereas like an hour or two on Paperspace costs you $1.50. So it might be worth just like doing the same process I just did for training using this new repo, and seeing if I can like train stuff. And my guess is that for training, I'm going to need to like find a whole test batch of images, probably thousands of images, maybe more, maybe less. Train it on like basically you'll need to find high-res images, and you'll need to like downsample them, and then that's how you train stuff. So this might be a process. Maybe I'm happy enough with the images it produced using the pre-trained model, but maybe I really, really want to go deep and see how like pristine I can make these images. So now I've got like a little bit more at hand, and I can like start to set up what a training might look like in Colab. But this is the basic process. I literally do this pretty much with every new model I look at. A lot of the models I just end up like sort of ditching. Like I might start writing a little bit of the Git cloning, and then I might like try to grab a pre-trained network, and like maybe the pre-trained network link is down and like it doesn't exist anymore, and I just sort of like, okay, time to move on. One thing I probably also didn't mention, like because we were looking at like some well-documented repos, is if you come into a repo and you hear that's like the next best thing, and there is no README, or like the README is like literally like go read our paper, but there's nothing here about like how to actually use it. And if you go into issues and you don't see anything, like one other thing I'll do is I'll go into issues and I'll look at the closed issues, and then you don't see anything like how does this work, that usually means that these people don't care if you use it. And I would recommend like it's not worth your time to even like try to work with them. So if you come in, you don't see any documentation, just skip it. It's not worth your time. No matter how perfect you think this thing is, it's just not worth your time to try to work on that. So with that negative ending there, take a walk through this, like try to set up the Python notebooks and the Colab work. And, again, I also have a Slack channel. You're always welcome to hit me up on Slack and ask me if I've ever tried stuff. I'm happy to maybe work on a new model if I think it's interesting. But you can always jump on Twitter and just be like, does anyone have a Python notebook for this type of thing? And maybe you'll find someone who does. So hopefully this helps you sort of start to learn post-class. But again, if you have any questions about any of this process, please feel free to hit me up on Slack or post a comment on the YouTube channel. Thanks.